Hi everybody, so this is partial fraction decomposition. Basically, it's just going the opposite of the addition or subtraction of two rationals, or basically two fractions itself. So when we're just doing examples so you can see what I mean by that kind of stuff. So what if we just wanted to add these two together? Okay. Focus mark. So what if we just want to add those two fractions together? So that means we would have the common denominator, so the common, or the LCD for short, would just be the multiplication of each one put together because they're just odd powers, right? Like that. So we will multiply this side by what's missing, so multiply this by x minus 2 top and bottom, and this side by x minus 3 top and bottom. So when we do that, that ends up being 4 times x minus 2 on the top, all over our LCD. And on this side, we would just multiply 1 times x minus 3, because that was what's missing on the other side. So distributing and then putting stuff together. Well, this is an 8. And then put everything over itself. Okay, so combining like terms gives us 5x minus 5 all over this stuff here. Okay, so essentially what's happening is, well, if I give you this, how can you give me the original two fractions when you multiply to give me that? So that's what decomposition means. It's just breaking the stuff down. So partial means a part of it is being decompositioned itself. And this is pretty big in calculus. This is one of the major things going into something called partial fractions integration. And basically, is you first have to do this algebra before you even do the integration. And that's where, these questions get pretty long just because of just the setup of it. Basically, is you want to break this down and make this integration part of an algebra and calculus much easier to deal with. And then once you get to calculus portion, you'll see why that's actually very important. But for now, well, there's a couple cases of broken down to 3 different cases on the level of difficulty. Obviously, case 1 will be the easiest, and then going down will be the most difficult. So case 1 is we have no repeated factors. So kind of like our example here, these are not repeated factors, they're unique factors. So that's what we can consider like case 1. And in this case, we'll say like A1, A2, A3 are just arbitrary values. So you don't have to put like A1, A2. You'll see me do like A, B, C, go down the alphabet. But basically saying it's just one number above the fraction. Okay. Case 2 is if we have repeated roots. And a repeated root looks like this. So for example, if we have like x minus 1 squared, right, that's a repeated root. So we would break this down completely, because this is the same thing as x minus 1 times x minus 1, right? So this is a factor, and then both of them put together would be a factor. So you would just start with one of them and then 2 of them. So if this is a 3, we do so the first power, second power, third power, again with a single number on top of the fraction. Okay. And case 3 is the most difficult part. Is, well, what if you have a quadratic that's unfactorable? Okay, so something that's unfactorable is not just a number, but has ax plus b on top, meaning it's a degree less than the one we have on top. And, in our cases, you're not going to see anything higher than squared, but it is technically doable for cubes, and that's okay. That goes into a whole other ballpark you really don't want to get into. Okay. Now, what I mean by unfactorable is stuff like this. Let's suppose we have that, right? So this is unfactorable on the bottom. So we would break this up as ax plus b over x squared minus 7x plus 1. Okay. Now this is actually a little different, because when I was in the class and learning this stuff in calculus, because I actually did with some pre-calculus, this is different than stuff like this. Okay. So the reason why I say this is different is because this doesn't have a squared, and this does. Okay, so this will just be a value over 2x minus 1, because that's technically a factor of it. So that's one thing you got to be careful of, is just because there's a number in front of x squared that's in front of x doesn't mean this is going to follow this format here. It's if you cannot factor this completely, right? This is considered a full factor form of it, so our unique factor of it. Okay, so Just a little precaution there. Just, usually it's unfactorable if you have a power on the x value, like cubes, fourths, squareds, all that fun stuff itself. Okay. So why don't we put this to practice so you can see how this is going to go about doing it. Okay. All right, let's do the first example. So we want to break this up into a partial fraction in each case. So no matter what, we're going to have to FOIL, or just factor in general, to see if we have unique factors, repeated factors, or if we cannot factor altogether. And this is a pretty straightforward one. I'll just do the work for you guys. So it'll be 6, -5 using the x method. So -3 and -2 would be our factors, just kind of like the ones we did on top, as you can tell. So let's see if it's actually these two, but probably not, right? Because it doesn't give you just x. All right, so now that we have this, so we could break it up. So now we're in case 1, basically. Okay, so case 1 says we have unique factors, so we just have a letter A over one of the factors plus a letter B over the other factor, like that. And our whole point is figuring out what an A, B is. And again, these are not variables, these are particular numbers that make this work. Okay, so kind of funny, but the way we do this is, well, what if we were actually putting these two fractions together, right? So like adding these fractions together, again, we would need common denominator. So in this case, our common denominator is just x minus 3 times x plus 2, minus 2. So therefore, what would I multiply this side by to get our common denominator, which hopefully everybody agrees is going to be x minus 3. And on this side, we would have to multiply by, on this side we have to multiply by x minus 2. And on this side we have to multiply by x minus 3, top and bottom. Now the key thing is that I really don't care about the bottom. Well, the most important is what's the top going to look like, right? Because the bottom, it's going to get that portion. So essentially, it's going to be a times x minus 2 plus b times x minus 3. And now the interesting part is, after we do this multiplication, it has to equal x on the very top. So now we just end up being, instead of fractions, we get a nice linear, well, kind of linear equation. Now at this point, depending on how the question is going to come into play, but most of the time you should be able to at least cancel some stuff out. And what I mean by that is, well, if you notice, if I let x equal 2, right? So if I just plug in 2 in for x, that means this is a 0, and a cancels out completely. So that means b is going to be by itself. So if you're not sure what I mean by it, just plug in 2 in for x, so on everything. So b here would be 2, a times 0, right, because that's going to be 0, plus b times 2 minus 3 is -1. So notice that goes away, and look at that. We can actually solve for b. So we know b is equal to -2. And that process comes back into play the same. So, okay, now if I do the same process, going back to our equation up here, well, how do I cancel out b? Well, what if I just plug in 3 now? Because 3 minus 3 gives you 0. And let's do the same process we did earlier. So if I just repeat this, it'll be 3 everywhere I see x. So a times 3 minus 2 is 1, plus b times 0, which is just 0. And notice, this actually isn't as bad as you may have thought. We get our two answers. So in this composition, we know it's going to be 3 over x minus 3 plus -2 over x minus 2. And that is our partial decomposition. So when you add these two fractions, you will actually literally get this as your result. So going backwards is far more difficult than going forwards. All right, let's try another one. So this is going to be breaking down. So first thing is we're going to factor an x out from the bottom. Okay. And then if we factor, we get x minus 1 times x minus 1, or just, x minus 1 squared. So this is actually a combination of case 1 and case 2, because we have a repeated root, right? This is being repeated twice. So if we go back to case 1, it's going to be a over x. That's the case 1 value, right? It's a unique non-repeated factor. But since now we have repeated factors, it's going to be plus b over x minus 1 plus c over x minus 1 squared. And that's what this comes into play, like this: first power, second power, third power. So if this was, again, to the fifth power, this would just go on for a chain, right? Cubed, fourth, and then fifth at the very end. Okay. And now at this point, we do the same thing we did above, right? So if I would, actually add these fractions together, what would I multiply this, right? So for example, here, what am I missing? I'm missing an x minus 1 squared to make the common denominator. So on this case, it will be x plus 2 is equal to a times x minus 1 squared plus. So if we go in the middle, what am I missing? So this one, I'm actually missing two things: the x from here, and also one more x minus 1. And then finally, c is only missing the x, right? That's the only thing I have to multiply this side to get the common denominator. And now we do the same thing. So is there a way we can cancel some stuff out? Now we have, a, b, and c, not just a, b. But we could do the same thing. We could say let's x equals 0, for instance, because 0 will cancel out here and also there because of this x right there. So plug in 0, we get 0 plus 2 is 2. This is going to be negative 1 squared, which is 1. B times 0, and it really doesn't matter what this is. And then c times 0. So notice aught goes away, so we found out what a equals 2. So same process works. So again, let's go back. So again, we're always looking at this equation. And now, how can I cancel everything else besides one of them? And well, let's follow the same template. Well, if I plug in 1 here, that goes away. So let's just let x equal 1. So if I let x equal 1, 1 plus 2 is going to be 3. A times 0 squared is just going to be 0. Plus b times 1 times 0 is still 0. Right? Just plug in there. Plus c times 1 is just c. And look at that, even nicer. Everything cancels and we get c equals to 3. Okay. All right, so at this point, we're wondering, okay, that's all I can do. I can't really plug in anything else to cancel out all the ones and just solve particularly for b. Now, this is where it comes kind of uniquely. At this point, because you already have a and b, A and c, and you're looking just for the other letter, you can literally let any number you want in for x. So I'll just plug in 2 for short. And you'll see what I mean by that. So if I let x equals 2, again, I'm just going to plug everywhere I see x equals 2. So on this side, it's going to be 4. On this side, it's going to be 1 squared. This is going to be b times 1 times another 1 plus 2c. Now you're thinking, well, what do I do now? Well, we know what a is and we know what c is. So let's plug them in. So b4 is equal to 2 plus, this is b, plus 6. Put it over here. So finishing up, b4 is equal to 8 plus b. Subtract it over, and we get b is equal to negative 4. So we get all our answers. So my final answer would be so 2 over x plus b, which is negative 4 over x minus 1, plus c, which is 3 over x minus 1 squared. And there's your partial decomposition for b. So again, this is a case 1, case 2 example. Okay. So now let's go on to the difficult one, case 3. All right, so again, this is a combination of case 1 and case 3. So the case 1 is a unique one, and case 3 is the unfactorable, because this is actually unfactorable, no matter what you want to do. What do we mean by factorable? Like using the x method, right? So 1 and 1, there's nothing you can add up to give you 1, right? There's nothing you can do. So at this point, we'll have our unique one, which is a over x minus 1. Again, that's the case 1 portion. And now for the case 3 part, So because it's unfactorable, we'll have bx plus c over x squared plus x plus 1. So that's how that works. So then this is the case 1, this is the case 3. All right, so at this point, we do the exact same thing we've done so far. So what are we missing to multiply? So on this side, we're just missing this, so it'll be a times all of that bad boy. And now this you gotta be careful of because it's bx plus c times x minus 1. Okay. Again, now we do the same thing. So using this format, is there anything we can put that in for x that cancels some stuff out? And we can start with, let's say, 1, for instance. So plug everywhere to see x for 1. So this is 3 minus 5 is negative 2. A times 1 plus 1 plus 1 plus, plug in 1, so it's b plus c times 0. And right, this is addition, so these cancel. So we just get everybody's favorite, some fractions. Right, so a is equal to negative 2/3. All right, so let's do the same thing. Now, it's a little trickier because we actually have this variable there. Right, so I can actually get rid of b by, again, just plugging x equals 0. Right, because 0 times anything will just cancel out. So let's just say the same thing. We'll just plug in 0 in for x and see what we get. So that's going to be negative 5 a times 0 plus 0 plus 1 over here, plus b times 0 plus c times negative 1. Okay, so that's negative 5 is equal to a plus, that's gone, minus c. And I think, okay, great, well, we know what c is, or so we know what a is, so we plug that in. So add it over, that's negative 4 1/3. And going backwards, so we know c is equal to positive 4 1/3. And I'll be consistent that that's 13/3. Okay. And again, at this point, we're still missing for b, so we just plug in any number we want for x, because we know what c and b is, or c and a is. So again, I'll just plug in x equals, let's say, 2. I don't want anything really big when it comes to it. So again, plugging in x equals 2 everywhere we see it. So that's going to be 6 minus 5 is 1. A times, this is going to be 4, plus 2 is 6, plus 1 is 7. And then plug in 2, so it'd be 2b plus c. And this going to be 1, because 2 minus 1 is 1. Okay, and then we just plug in everything we know, right? So plug that in for a. So that's going to be negative 14/3 plus 2b plus c, which is 13/3. And notice that's kind of nice. These are already have common denominators, so we can just subtract them straight across. So you get 1 is equal to 1/3 plus 2b. Subtract it over. We get 2/3. Divide both sides by 2. And we get b is equal to 1/3, I believe. Yeah. So we got our a, b, and c. So my final answer would be, and you can just leave it like that most of the time. Depending on your professor, I'll show you a different way of rearranging this kind of stuff as well. So that's technically fine. However, if you're going to the integration part of this, another way to write your answer would look like this. Like that. So they would just bring the 3 down, factor out the 1/3, and bring it down here as well. So that's an alternative way of doing it as well. All right, so I'm going to just do a couple more practice problems, give you guys a little bit better to do so. All right, so why don't we start off with the hardest one of all? And this is actually the hardest one of all, believe it or not. So I don't know why I did this to myself, but this will take a while. All right, so this is a combination of case 2 and 1. Nope, just case 2. So this is going to be a over x plus b over x squared, because that's a double root, right? It's a repeated root, plus c over x minus 1 plus d over x minus 1 squared plus e over x minus 1 to the 3rd power. So you're like, that's a lot of stuff to deal with. Okay. So again, it's going to look really messy, but we got to do this. So again, if I would multiply everything, I'm going to try to write a little bit smaller too. So what I'm missing on this side is literally one more x and the cube, right? So the x minus 1 to the 3rd power plus, and you just got to be careful, right, to see what's missing. So over here, I already have the x squared, so I'm just missing the cube part. For the c part, I'm missing all the x's and 2 squareds, right? For d, I'm missing again all the x's and just a single x minus 1. And then for e, all I'm missing is the x squared, because I already have the cubes in place. Right. Now again, at this point, let's do the exact same thing. So we're going to let x equal, let's say 0, because that cancels a couple things out. Right. So letting x equal 0, notice that all goes away, so we just get -8. All that cancels because there's a 0 there. So that goes away, that goes away, that goes away. Look, even that goes away, which is kind of nice. So pretty much the only thing that's standing is right here. And then we have 0 minus 1 is -1. Cube it gives me -1. So let's be negative b. Ah, look at that. So we got b has to equal 8. And again, let's do the same thing. So we're going to let x equal 1 and see what happens there. So again, if I let x equals 1, those cancel, so that goes 0. That's goes 0, that's go to 0, and also that goes to 0, right? So the only left standing is right here. So 1 minus 8 is -7, and this is going to be e. So look at that. There we go. So right off the bat, we already got 2 down. So b is 8, and e is -7. So the question becomes, well, I got to do this, there's 5 different letters I got to figure out. I only got 2. I still have 3 more to go, right? So I still need A, C, and D. How in the world do I do that? Well, unfortunately, that's where the fun comes into play. And, I guess fun can be kind of relative, depending on how you want to look at it. So, first, let's FOIL this out. So what I mean by foiling it, right, is just, literally just FOIL it out. Right. So this is going to be x squared minus 2x plus 1. And then re-FOILing this out. And then just combining everything we can. And there we go. Okay, so why don't we replace that over here, okay, with everything else. So I'm just going to rewrite it. Let's just write it here, make it easier. So I have x to the third minus 8 is equal to a. And since it's a, as there's an x out here, I'm just going to rewrite that with a multiplication in here. So I'll just do each step at a time. Plus b, and this one's just itself again. And then c, and that one's x, so it's going to be just this one. Plus d times x squared just times x minus 1. And we're getting alone e to the x squared there. Okay. So now let's distribute everything we possibly can and see what's going on. So what I mean by just straight out distribute on every single case. Okay. All right, so at this point, let's have a different colors here. Okay. So we have a to the fourths. Okay. So I'm going to put those together. What I mean by that is like this. That. So I'm just going to cross those out because I use them. And now Q's. All right. Okay, now we'll go to squareds. All right, so I did those. All right, X's. And then finally the single ones. All right, so here's the fun part. Now you may think this is an absolute mess, and actually isn't. It's really nicely ordered. That's the reason why it's a horrible, looks like a horrible mess, and it takes a long time, but it's actually kind of interesting how it works. Okay, so remember, all of this must equal that. So the question is, do we have any x to the fourths over here? No, we don't, right? The highest is x to the third. So we know that a plus c must equal 0 because we don't have any, we have 0 x to the fourth over here. And we use that same pattern going down. So therefore, we do have x to the thirds. That's the single variable of 1. So 1, because that's the coefficient in front of x to the third, must equal this whole mess here. And now again, going down now, x squareds, well again, we don't have any x squareds, so therefore all of this must also equal 0 because we have 0 x squareds. So all of this sum with all of this horrible variables everywhere. Okay. Again, do we have any x's? Single x's, and that's still no. So again, all of this must equal 0. And we already know what b is, right? That's where we saw earlier. That's the reason why b has to equal 8, because that's the only single variable there. Now, you may think this is still even horrible, but actually we're already done because we did the work already right here. I can find what a is just by plugging in what b is. So b is 8, and if I just solve for it, so therefore my new equation is going to equal a. 0 is equal to negative a plus 3 times 8 is 24. Well, solving for a means just subtract it over, so therefore a must equal 24. And now we just work our way backwards. Let's go over here. Well, we'd solve for c now. So 24 plus c equals 0. So therefore c must equal negative 24. And I'll rewrite the ones we had earlier. So b we found to be 8, and e we found to be negative 7. So notice we're pretty much done. We just need one more letter. We have a, b, c. Now we just need d. And for d, you can literally use any of these two equations to do so. So just for fun, I'll just use the first one here. So we know 1 must equal negative 3 times a. So negative 3 times 24 is 72. So negative 72 plus b, which is 8, minus 2 times c. So that's going to be positive 48 plus d. And then just solve for d. That's going to be 56. I believe that is 16. Yeah, 16. Subtract it over, so d must equal 17. And there we go. So finally, we can have our answer. So all this horrible mess ends up being 24 over x plus 8 over x squared plus negative 24 over x minus 1 plus 17 over x minus 1 squared plus, and what was e? Negative 7. Negative 7 over x minus 1 to the third power. So get the hardest one out of the way first, right, when it comes to it. Okay. All right, let's try b now. So b is case 2 and 3. So the reason why is because we're going to have repeated factor of x squared plus 4 to the first power plus x squared plus 4 squared. Okay. So again, these are unfactorable, so I have to have ax plus b and cx plus d. So these two are two factors of it. So each one has a top again because it's unfactorable, hence we have a square there, right? Okay. Again, looks horrible. That's actually, after the first one, anything makes, life a lot easier itself. So on this side, we're going to multiply this whole thing by one of it, because we only need one of it. And the nice thing is on the other side, we have everything. So it's literally just that. So again, we need 4 letters. We can kind of subsidize, right? So again, also let x equal, let's say, 0. Or can we do that? We get 0, so it cancels. Oh, no, we can't do anything. Well, guess what? That means we just got to do the rule we did above. So let's just distribute here and just do the same rule we did earlier. So if I distribute, and again, we're just going to break them up into groups. That's it. Like that. Now look at that. We know, well, there's only one x to the third here, so therefore by default, 1 has to equal a. That's the only number in front of x to the third. And by default, b also must equal 1. Well, look at that. We're halfway done. We got what a and b is. So again, setting up the other portions, we know, well, sorry, this is supposed to be next, that 4a plus c must equal 0, and 4b plus d must equal 0 as well. Well, we just plug in what we know. Well, a is 1, so we have 4 plus c equals 0, so c must equal -4. And on this side, we have 4 plus d equals 0, so d also equals -4. So we got our answers. So much easier than the last one, right? So we plug in everything. So a is 1, so we have 1 plus 1 over x squared plus 4 plus, and then c and d are the same. So -4x minus 4 all over that squared. And there's our partial fraction there. So funny thing is how I made it. I did not expect to make it difficult from hardest to easiest, because C is the easiest of all of them. This is just case 1. So maybe I kind of should have flipped it around, go from easy to hard. But yeah, once you get the hard ones out of the way, everything else is easy, right? So this is going to be case 1, so just 2 different factors. So this is going to be much faster itself. So what's missing is the x minus 1. What's missing is the x plus 2. And now we could just let x equal 2 different things, right? So let x equal -2. That cancels this. So you get -6 is equal to a times -3. So a is going to equal to 2. That's not that bad, right? So, and then we're going to let x equals, let's say, 1. So that goes away. So we get 3 is equal to 3b. So b must equal 1. So notice this is way easier, right? So we have 2 over x plus 2 plus 1 over x minus 1 as our partial fraction decomposition. Okay. And there you go. So after this horrible mess, we finally learned partial fraction decomposition.